Question B1. Question B1. This question is about the photoelectric effect. It says a clean metal surface in a vacuum is illuminated with monochromatic light, that means light all of one frequency or wavelength, resulting in the emission of electrons from the surface. On the axis, sketch a graph to show how the maximum kinetic energy K of the electron varies with the intensity I of light. Now, we need to remember that our formula over here, these two formula over here apply, along with obviously this one over here, the photoelectric effect, the energy of a photon. But these two are our major formulas over here. And we can see that if we write them, HF is equal to phi plus E max. Now this over here is your work function, and this is the energy of the photon, the incoming photon here. So as you can see, there's nothing to do with intensity in this, where intensity would be purely the number of photons, but the energy of the photons depends, this kinetic energy depends on the frequency of the light. This is the determining factor of the energy of a photon. So your maximum kinetic energy is going to remain the same as you increase the intensity. Or what you're going to do is you're going to have more photons, therefore more electrons, but the amount of energy that they have would be the same. So explain the shape of the graph that you have drawn. We are just going to be putting those points down here. Now notice you've got 3 marks, so you need to give 3 valid reasons. The first thing that needs to be stated, what it all depends on, is what Einstein said, that light consists of photons. So you have light consisting of photons, and the energy of these photons is proportional to the frequency. Depends only on the frequency, not on anything else, not on the intensity at all. And therefore the maximum E max will therefore also be proportional to the frequency of the incoming light. And therefore it is independent, does not depend, alright, it does not depend on the intensity of the light. And therefore when you increase the intensity, all you're doing is you would just have an increase in the intensity, just gives more photons, but with the same energy. Okay, so those points should be included in your answer. Then we have here the wavelength of the incident light is in A is 400 nanometers. This small n over here is 10 to the minus 9. The maximum kinetic energy of the emitted electrons is 2.1 eV. Determine the work function of the metal. So obviously we're going to be using this formula over here. So we've got HF is equal to our work function plus our Emax, like that. Because we are dealing with the wavelength, we'll just rewrite this formula, because obviously we know that the speed of light is equal to frequency times wavelength. Frequency is equal to c divided by wavelength. So we're going to get hc over lambda minus E max is equal to your phi. And so we just need to put that all in. So we're going to get h at 6.63 times 10 to the negative 34 times your times the speed of light, which is 3 times 10 to the 8, divided by your wavelength, which is 400 times 10 to the negative 9. And now we're going to minus our Emax, but this Emax, because this HF here is in joules, this Emax is in joules, so we're going to have to do a conversion from our electron volt into a joule. And as we know, when you go from EV into joules, we must multiply by 1.6 times 10 to the negative 19. So it's going to be minus 2.1 times 1.6 times 10 to the negative 19. And that will give us, in joules, our work function. And when we do that, when we put that all in, we will get 1.6 times 10 to the negative 16 joules. Or should be times 10 to the negative 19, and that is 1 EV, 1.0 EV.